Hello everyone. We will solve question number 22 from GATE 2022. This is a topology question. So we have given a topological space 0, 1, T1, where T1 is the subspace topology induced by the Euclidean topology on R, and T2 is any topology on 0, 1. So we have given two statements. Statement P is if T1 is a proper subset of T2, then the topological space 0, 1, T2 is not compact. And statement Q is if T2 is a proper subset of T1, then the topological space 0, 1, T2 is not Hausdorff. So we have to check if statement P is true or false and statement Q is true or false. So let's get started. Now, first let's check for statement P. So T1 is a proper subset of T2. This means T1 is not equal to T2, but T1 is a subset of T2. This means there exists some set U in T2 which is not in T1. This means U is open with respect to T2, but U is not open with respect to T1. Let F is equal to 0, 1 minus U. Then F is closed with respect to T2. But it is not closed with respect to T1 because its complement is not open with respect to T1. Now, we have to check if 0, 1, T2 is compact or not. So suppose it is compact. Suppose T2 is compact. Now we know that a closed set in a compact topology is compact. Now F is closed with respect to T2. So F is also compact with respect to T2. Right. Now let's check if F is compact with respect to T1. So let alpha be an open cover of F in T1. Now T1 is a subset of T2. So every set that is open with respect to T1, it is also open with respect to T2. So this implies alpha is an open cover of F in T2 as well. Since F is compact with respect to T2, there exists a finite subcover. Say beta of F. So this means that F is also compact in T1. Now, see, 0, 1 is a closed interval in R. So 0, 1 is compact in R with Euclidean topology, of course. So 0, 1 is compact and F is a compact set in T1. So we know that compact subset of a compact space is closed, right? So what does this mean? This means that F is closed in T1. But by our assumptions, what did we had? That f is not closed with respect to t1, right? So this is a contradiction. Therefore, our assumption that T2 is compact, it is not correct. It is wrong. So we got that if T1 is a proper subset of T2, then T2 is not compact. So statement P is true, right? So P true. Now let's check for statement Q. What is statement Q? If T2 is a proper subset of T1, then 0, 1, T2 is not Hausdorff. So the proof is in a similar way. Let's just check. So we have, let T2 is a proper subset of T1. So the similar proof will follow. So there exists V in T1 such that V is not in T2, right? So this means that V is open with respect to T1, but it is not open with respect to T2. Now let C is equal to 0, 1 minus V. So this implies C is closed with respect to T1, but not with respect to T2, right? Now we already know that 0, 1, T1, this is compact topology, and any closed subset of a compact topological space is compact. This implies C is compact in T1, right? Now, by following the similar argument that we followed in proving the statement P is true, it follows that C is compact in T2. Because if we take any open cover of C in T2, then it will be an open cover in T1 because T2 is a subset of T1. So now there will exist a finite subcover, right? So it means that C1 is compact in T2. Now, what is statement Q? It is if this, then this. So we assume that T2 is a proper subset of T1, and we have to check if T2 is Hausdorff or not. So just we'll assume that suppose T2 is Hausdorff. Let's see what happens if we arrive at any contradiction or the statement is true. Let's check. Now T2 is Hausdorff and C is compact in T2. We know that a compact subset of a Hausdorff topological space is closed, right? So C is a compact subset of Hausdorff topological space T2. So this implies C is closed with respect to T2. But what was our assumption? By our assumption, we got that it is not closed with respect to T2. So this is a contradiction. Therefore, here this assumption is wrong. This implies T2 is not Hausdorff. Thus, what did we show? We assumed that T2 is a proper subset of T1, and we showed that T2 is not Hausdorff, right? That means statement Q is also true. Thus, both the statements are true, right? So, it is option B. Therefore, option B is the correct option. Okay, so I hope you all understood this solution. See you in the next video. Thank you.